Hey guys, welcome back. We're going to start our next unit, which is over similarity. It's actually something similar to what we've seen before with dilations, I know, pun intended. But before we do that, we need to go over some of the most missed problems I saw from the test. So these are the top 3 most missed problems. You can see the percent of people that missed them, so 58, 71, and 45%. And whenever I show you what you're doing wrong, you're going to feel pretty silly. And so basically, a week after we take the test, tomorrow, I will circle the ones you missed, and the week after we take the test, I will go over we will do retakes is what I'm trying to say. All right, so let's look at the first one that a lot of people miss, 58%. So on this one, they want us to solve for the measurement of angle 3. Well, first we look at these opposite angles of a parallelogram because the opposite sides are parallel. Those two have to be equal, so we do 4x is equal to 2x plus 30. Then we can solve for x. The problem that I had is that most people, the answers were actually plugging it in for angle 3. So once we get that, we get 2x is equal to 30, so x is 15. When we plug it in, we get 60. So if this is 60 degrees, angle 3 has to be 120 degrees, which is a supplement of 60. Now, a lot of people said that the answer was that the measurement of angle 3 was equal to 15, but that's not true. X is equal to 15, so just be careful with that. Then on number 2, the shape we have is a kite. We have 2 consecutive sides that are congruent. These 2 sides are congruent as well. So it's not a parallelogram, so the opposite angles are not going to be congruent. But on this one, we have a line of symmetry. In this case, because that side's corresponding with that one goes with that one, we have a horizontal line of symmetry. So anything that's on this side is going to be the same as that side as well, which means that angle x and angle 108 are going to be exactly the same. So x would be 108. But this 62 degrees, that one actually gets cut in half. So you could cut it in half if you wanted to. That would make this, 31 degrees. And then you could say, so that was 108, then 31, and then you could solve for the missing one here. But that's more work than you actually have to do. We do know that this is a quadrilateral, so all the angles have to add up to 360. So that's what I would do. Add them up, set them equal to 360. So we have 108 and 108, which is going to be 208. Then I'm adding the 62, which is going to put us at 272, I believe. Yeah, so we have y plus 272 is going to be equal to 360 degrees. Then we can do our algebra from there. So subtract 272 from both sides, so minus 272, which leave us with y is equal to the difference between those two. So anyway, lots of different things we saw on that one. Just make sure you look at your line of symmetry, and then remember that all of these add up to 360 degrees is kind of what you're going to need to know for that one. All right, number 3, 45 degrees, 45%. Ooh, man, it's late. I need to get more sleep apparently. All right, so we do have a right angle. Make sure you don't forget that right in the 90 degrees, otherwise you're likely to forget it. The other angle that you guys actually forgot on this one was actually the 8 degrees. So you remember the 90, but you forgot the 8. So anyway, add them all up. We've got 5 sides, so 5 minus 2 is 3. 3 times 180 is 540. So all these add up to 540. Add our x's together. We have 5x plus 90 plus 122 plus the 8. It's going to be 100 or 220. It's all going to add up to 540. Then we subtract 220 from both sides. We get 5x is equal to the difference of 32. So x is going to be equal to, in this case, 64 degrees. So something similar to that. The problems that we saw, again, not that you forgot the 90, which was something I already warned you about, but you forgot the 8 degrees that was with this constant term here as well. So just be careful. Make sure you add all of your constants together. Yeah, so that was it. So let's move on to the next stuff, which is starting our new chapter of similarity. And the most important part that we're going to do with similarity today is looking at ratios and proportions. Now, this is stuff that you should have known from middle school, and should have done quite a bit of this stuff before, but maybe we're looking at it a little bit differently than you have before. So some people might find today to be a little bit challenging. That's why I wanted to do it in person. So I'll try to do my best on the video, and we'll get going. So congruency versus similarity. So whenever we have a congruency symbol here, it's actually made up of 2 parts. We have the tilde and we have the equal sign. So you know this, right? The tilde part means it has the same shape, which means that all the angles are the same. And the equal sign means that it has the same magnitude or the same size, which comes from the lengths of the sides. So if we put that together, we can say that 2 triangles are congruent if they have the same shape and the same angles, or the same shape and same size, which means they have the same corresponding angles and sides are all congruent. So in this case over here, we have a parallel lines. We have 2 transversals cutting them, so they're going to have alternate interior angles. So I know those angles are going to be the same as those angles there. But if I know nothing else, I also know vertical angles are the same, or third angles theorem. If I know nothing else, I know they have the same similar shape because they have the same angles, but I don't know that they're going to be congruent unless I know one of the sides, right? So as I move this to the left and the right here, you'll notice that those angles stay exactly the same, which is pretty cool. So both of these angles are the same. They're still alternate interior angles because our parallel lines didn't change. And as long as I'm just moving this left and right and it's still the same slope, it's pretty cool. The vertical angles are always congruent. That's just like mesmerizing. Whoa. Okay, I'm so easily entertained apparently. But anyway, at all times, if they have the same angles, it means that they're going to be similar and they have the same shape as well. And we're going to be able to talk about how the sides will be proportional to each other and stuff like that when we get into similarity, proving it with angle, angle, side, 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 and side, angle, side. In fact, next time we come back in person again, which would be like next Monday or next Thursday, we're going to have an activity that we're going to do together, which is going to be a ton of fun. So I'm looking forward to that with you as well. Now, at a certain time, whenever we pass through the midpoint, so whenever this cuts it in half, we now know that one of the sides are the same as well. And we could actually prove that these two triangles at this point, if it goes through the midpoint and bisecting each other or whatever, then that these two triangles at that time would also have the same size instead of just being, you know, smaller or bigger, right? Proportional. So this one is some proportion of this one down there at that time. Okay, so whenever it goes through the midpoint, then we can actually prove they're congruent by angle, angle, side. So AAS. Congruency. So both of these would be the same. So not only are they the same shape, but they're also the same size. So we put those two symbols together, which would mean that they're congruent. So similarity is just going to be the symbol, the tilde symbol, where congruency is a special case of similarity when they have a ratio of 1 to 1 or a scale factor of 1. So pretty much this is what we're getting into here. So we've actually seen scale factor before with dilation. So we actually multiplied by that scale factor. And if you remember then, we had our pre-image and our image. So we're starting out with a small triangle. We blew it up just like we blew up our puppies to get our big image here. Then the question that we'd have is how do we find the scale factor? Well, the scale factor was actually shown with the points here. That was part of it, right? So if I go from 2 and 1 to 6 and 3, what did I multiply it by? Well, 2 times what is 6? Well, we're multiplying it by 3, clearly. So another thing you can do is you can take the length, like we have down here. We have a length of 6 on the bottom, and here we have a length of 2 on the bottom. And I'm going to do the image divided by the pre-image, so corresponding parts. So 6 divided by 2, which is going to give me a reduced fraction of 3. So we have a scale factor of 3. You can also see it kind of shown here. So what if I have the side length of radical 5, then radical 5 times 3 would be 3 radical 5, right? So here, basically, any corresponding parts can be multiplied by 3. The same thing is going to be here. So that side is going to be multiplied by 3, which would also be 5 rad 3. And this side over here is also going to be multiplied by 3. So 2 times 3 is 6. So our scale factor is what we're multiplying by to go from our pre-image to our image, essentially, which is not too bad. The next thing that we're going to talk about is ratio. So ratio is going to go from the pre-image to the image, pretty much. So in this case, basically just take 2 going to 6, or you can do radical 5 going to 3 rad 5, but I'll do 2 and 6. So 2 goes to 6, then we can reduce the ratio just like we reduced the fraction, and that's going to be a reduced ratio of 1 to 3. Now if you notice, there is a difference. The scale factor is kind of flipped from what we do with the ratio from the pre-image to the image. So it's going from 1 to a 3, which means our scale factor was 3 over 1 or 3, because we multiply it by 3. In other words, so slight difference between the two, but really, I mean, they're very similar. And many times you can solve these by setting up proportions with the ratios, or you can just multiply by the scale factor if you can see it, if it's easy enough to see. So let's look at similarity in real life. So here we have a scaled down model, which has a ratio of 1 centimeter to 2 feet. That's what our scale is. It's just a ratio. Okay. So how big are these dimensions in real life? So 1 goes to 2. So basically we're just multiplying it by 2. Now our dimensions, our units are changing as well. We're going from centimeters to feet. So there's a conversion factor there. I think there's like, what, 30 or 33 centimeters in a foot, or 31. So basically we're multiplying it. It's like 64 times as big, or it's a 1 to 64 scale. But for ours, it just looks like we're going from centimeters to feet, so we're multiplying by 2. So this side here of 11 is going to be multiplied times 2, which is going to go from 11 to 22 feet, right? 10 is going to be multiplied 10 times 2 would give us this side length here of 20 feet, right? And then lastly, we have down here, we have 3 times 2, which would be 6. So we have all of the dimensions. All we did is multiply by our scale factor, which in this case was just simply times 2. So our scale factor is the image divided by pre-image, so 22 divided by 11, or 2 divided by 1 if we're doing the ratio down here, which is just going to be 2. And our ratio from our pre-image to our image is 3 to 6 or 1 to 2 if we're just using the thing that they gave us. So 1 centimeter to 2 feet, and that's already reduced, and that's reduced as well, so good to go. We also see scales on maps. So for instance, from Winston-Salem to Raleigh, North Carolina is 1.85 centimeters. I actually found this on Google Maps, so this is true. So 1.85 centimeters, and our scale is going to be down here. So 2 centimeters in the real world is going to be 50 miles on the map. So our ratio is 2 centimeters goes to 50 miles. So we can set up a proportion. So 2 goes to 50. So 2 centimeters goes to 50 miles, just as 1.85 centimeters on the map goes to how many miles in the real life. Well, all we'd have to do at this point is cross multiply. So we're going to do 2 times x, or 2x, is equal to 1.85 times 50. And then all we do is divide both sides by 2. And so we have 1.85 times 150 divided by 2, which will give us what x is equal to, which is going to be 46.25 miles in real life. So this is where I have this awesome meme from Dumb and Dumber. So anyway, according to the map, we've only gotten 4 inches, so we've got a long way to go to get to Aspen. Anyway, so proportions. Lots of different ways you can set up a proportion. So here we have 2 similar triangles. Obviously, the blue part goes with blue and the red goes with the red. So x is going to 8, just as 2 goes to 16. We could also set it up, 8 goes to x, as 16 goes to 2. So let's just kind of see all the different ways. So x goes to 8, just as 2 goes to 16. That would be legit. And if we cross multiply, we'll get 16 is equal to 16x, so x is equal to 1, right? Okay, so surely that's fine. All right, 8 goes to 16. 8 goes to 16, just as x goes to 2. Okay, just make sure we're doing it in the same order. So 8 goes to 16, just as x goes to 2. So whatever pattern you do on the first one, just make sure you do it on the other one as well. Same thing if we cross multiply, we get 16 is equal to 16x, so x is equal to 1. All right, other ways we can do it. Let me move these down here so a little bit further out. X goes to 2. So x goes to 2, just as 8 goes to 16. That'll work just fine. Or we can do 16 goes to 2. 16 goes to 2, just as 8 goes to x. All right, so the whole point of this exercise is to show you there's 4 different ways to set up any proportion. They'll all give you the exact same answer. Notice also the patterns. The red ones, the corresponding parts were either next to each other on the bottom, they're both ways, or they're lined up vertically. We could also do it flip that way, or we could flip it the other way as well. Yeah, so lots of different ways, and the blue ones are lined up as well. The only way to mess it up is if you cross them, like if you go in a circle. So let's see what this would be. This is wrong, by the way. So 8 goes to 16, just as 2 goes to x. Yeah, that would be wrong, right? So we can't go 8 to 16, 2 to x. So basically, just make sure you line them up just like you think. It works, setting up proportions. Extended ratios for the sides of a triangle. So on this one, we have 3 sides of a triangle. We're going to write the extended ratio. We always write extended ratios from least to greatest. So our smallest side is 8, and then 16 and 24. But just like reducing a fraction, we can reduce ratios as well. So I'm going to divide these by 2, I think. So that's going to give me 4, 8, and 12. But you notice we can actually divide it by 2 again, which will be 2, or we can actually divide it by 4. Okay, so 1, 2, and 3. So our reduced extended ratio, and we'll always reduce them down, is going to be 1, 2, and 3. So this is, we can say that the this triangle is a 1, 2, 3 triangle, or the extended ratio of the sides is 1 to 2 to 3, or at least it's similar to one of those. And then it's just multiplied by a scale factor of 8, right? If you notice here, we're multiplying 1 times 8. And in fact, everything 2 times 8 and 3 times 8 as well. So extended ratio. Proportion. So let's set up one here. So we have 3 goes to x. So 3 goes to x, just as 5 goes to 25. So we set it up. We're good. The next thing we would have is we'd actually want to, you could cross multiply if you want to, but on this one, it's actually pretty simple. You might even be able to see what the scale factor is. So on this one, what am I multiplying by to go from 5 to 25? Well, just times 5, right? So what's 3 going to turn into? 3 times 5 as well is going to be 15. So x in this case has to be 15. So oftentimes you can set up a proportion, but oftentimes they'll be simple enough you actually see the scale factor right off the bat. So that's totally valid. You can do that. If we didn't, there's other ways we could do it. But anyway, so image divided by pre-image would be 25 divided by 5, which would be 5. Our ratio is going from 5 to 25, which reduces to 1 to 5. So notice that those two are just the reciprocals of each other. We could also set up the proportion 3 goes to x just as 5 goes to 25, or 3 goes to 5 just as x goes to 25, or x goes to 25 just as 3 goes to 5. Okay, cool. So lots of different ways, and if we cross multiply, they'll all work. Another thing I do want to point out is before we cross multiply, we can actually reduce ratios. We can reduce ratios just like we reduce fractions, so that would be 1/5, which makes it easier to solve, right? So 1 goes to 3 just as 5 goes to x. You can solve that, no big deal. Same thing here. We can reduce the ratios here. That would be 1 goes to 5. But because we can set up our fractions or our proportions vertically or horizontally, it actually allows us to reduce ratios horizontally as well. So we could also reduce that as 1 to 5. So just keep that in mind when we're reducing or simplifying our fractions before we cross multiply to solve our proportions. You can reduce them just like a fraction would typically, but it actually allows us in this case to reduce the denominators or the numerators and reduce them horizontally, which is really, really helpful to be able to do that. And that's because we can set them up that way. So it's kind of nice. All right, so what about other one-dimensional units? So like the perimeter. So these two are similar because well, we can see like our scale factor here. If I go from 5 to 25, what am I multiplying by? Well, I'm multiplying by 5, right? Okay, so if I go from 3 to 15, I'm also multiplying by 5. And so it's the same scale factor. They're growing at the same ratio or at the same rate. So they are going to be similar to each other. Our scale factor is going to be 15 divided by 3, which is 5. In other words, our ratio would be 5 to 25 or 1 to 5. Okay, so you got your ratio, you got your scale factor. So what's the perimeter? Well, that would be 3 and 5, right? This one's going to be 15 and 25. So the perimeter of our small one would be 16, and the perimeter of our big one would be, I think it's 80? Yeah, 80. So what's our scale factor going from 16 to 80? Well, if you notice, it's exactly the same. Same scale factors we have with any one-dimensional measurement. The distance around the side is just another, the perimeter is just another one-dimensional measurement, and so it's going to have the exact same scale factor, which is pretty cool, actually. All right, so let's do another example. Here we have two similar triangles, and we'll learn how to prove those. Just roll with me on this one. So 3 goes to the longer one of 6, just as d plus 1 goes to d plus 5. So 3 goes to 6, just as d plus 1 goes to d plus 5. We also could set it up like this. 3 goes to 6, just as d plus 1 goes to d plus 5. Now, the reason we could do it both ways is whenever we cross multiply, those two are going to be multiplied together, right? So 6 times d plus 1 is the same thing as d plus 1 times 6. Kind of cool. Huh, fun stuff. Lots of math going on here with ratios and proportions. All right, so let's start the assignment. Not too far in, not too bad. So this first one, we're actually going to look at the ratios, but we want to change them so they're in the same units first. We didn't do that earlier with the scale model of the boat, but we actually want to do it so that we know what's the actual scale ratio. So we need to use the same units. So on number 1, we have the diameter of a salad plate, which is 8 inches, and the diameter of a dinner plate, which is 1 foot. So the first thing I want to do is change it to inches so that we're using the same unit. So that's going to be 12 inches. So our ratio is going to be 8 to 12, okay? And then the reduced ratio is going to be what we can divide it by, just like if this was a fraction, like if it was 8 over 12, what's the reduced fraction? Well, we can take out 4 from both of them, right? So that's going to give us 2 over 3. All right, just like reducing a fraction, we're going to do the same thing, reduce the ratio. So pull 4 out of both of them, leaving us with a reduced ratio of 2 to 3. And then our scale factor is going to be, should be not a over b, it should be b over a. So that is actually backwards. So I might need to fix that. I think I did. I just forgot to update it on this one. But anyway, it should be b over a. So it's going to be 3 over 2, which is 3 halves, which is 1.5. All right, so the weight of a cake is 1 ounce. The weight of a cake is 2 pounds and 2 ounces, or 2 ounces and 2 pounds and 2 ounces. Well, on this one, you're going to have to know how many ounces are in a pound. It's actually 16. So 16 times 2 would be 32, plus 1 plus 2 more would be 34 ounces. So kind of good to know that one. Some of you guys might know some of that better than others, but that's okay. So our ratio is going to be 2 ounces to 34 ounces. If you notice, you can take a 2 out of both of these. So our reduced ratio would be 1 to 17 ounces, and our scale factor would be 17 over 1, which is just 17. So our cake is going to be 17 times the weight of the cake is 17 times that of the weight of the cupcake. Use the given ratios to label the diagrams where x is our scale factor, then write the equation using x as a scale factor to solve for unknown dimensions. So the perimeter of a rectangle is 280 centimeters. The ratio of the height to the width is 3 to 4. What's the perimeter of our model? So we're going to have our model comes from the reduced ratio of 3 to 4. So it's like 3x and 4x, where x is the scale factor we're multiplying to go from our model back to the original unreduced ratio of the actual one. So in this one, they told us the perimeter of the actual one was 280 centimeters. So what we want to do is find the perimeter of our model first. So that's 3x and 4x, which would be 7, or sorry, if we're doing the whole perimeter, that's going to be the same on both sides. So it would be 14x, right? So we're going from 14x to a 280. So then the next question is, what's our ratio? So the ratio is going to be from 14 to 280, which if we reduce that down, it's going to be a ratio of 1 to 20, I believe. Yeah, so it would be 1 to 20. So what's our scale factor? Well, that's going to be 280 divided by 14, which is simply going to be 20. So now that we know our scale factor is 20, we can find the length of the height of the actual rectangle. Well, they said the ratio of the height to the width is 3 to 4. So the height would be corresponding with the 3x. So we want to do 3x times 20, which would give us, or 3 times 20, because the x is the scale factor in this case, which would give us 60. So the actual one would be 60. So this one here would be 60, and then 4 times 20 would be 80. If we add that together, so 60, 60, 80, 80, that should all add up to our 280, which is kind of what we're doing. So we're actually using what we know about ratios and proportions in order to go from a reduced ratio back to the original unreduced ratio. So kind of some tricky stuff here. I get it. So if you're struggling, that's okay. Let's look at number 8. So this is a question that you would see before. A music collection has 3 jazz albums for every 2 country albums. What's the ratio of the country albums to the jazz albums? So country is 2, jazz is 3. So there'll be a ratio of 2 to 3, right? They just kind of flipped it for us. If the music collection has 45 albums altogether, what's the scale factor from a reduced ratio to the actual? Well, if we add these two together, this is our reduced ratio, right? We always reduce it. And we're kind of trying to work backwards to find out what it started out with. So if we add those together, that's going to be a total of 5. So in our little small model of 2 to 3, it's going to be 5 altogether. So we're going to go from 5 to 45. So what are we multiplying by? So 45 divided by 5, which is like our image divided by pre-image, would give us 9. So basically our scale factor is going to be 9. So it's 9 times these numbers here. So how many country albums? Well, 2 was representing the country, so 2 times 9 would be 18. And 3 was representing the jazz album, so 3 times 9 would be 27. If we add those two together, sure enough, they add up to the 45. So if you see what happened is we actually started out with a ratio of 18 to 27, and then we were able to reduce that ratio by pulling out the scale factor of 9, which is what brought it down to 2 to 3. So basically we're just trying to work backwards to find out what we start out with our unreduced ratio, if we know what they add up to, how many are in total, and what the ratio is. Okay, so good questions here. Moving on, number 10, cross multiply to solve for the value of the missing variable in the proportions. So we're going to cross multiply. Now before I multiply, if I notice these are even numbers, I know that I can reduce them, right? So 16 and 40, we can actually pull out 4 from both of them. Or no, 8. We can pull out 8. So that's going to be 2 on the top and then 5 on the bottom. So we can reduce that ratio or that fraction before we cross multiply. It's going to make our numbers smaller, so we should probably do it. Now we can't reduce horizontally on these because we have x terms and there's no x's in here. Otherwise you have to factor them out and reduce either a common factor. So nothing else we can do there. So next thing I'm going to do is cross multiply. So I'm going to do x times 5, which is 5x, and then 2 times 2x plus 1. And then I have to distribute through there, right? So that's going to be what, 4x plus 2 and 5x. Then we're going to subtract 4x from both sides, so we get x is equal to 2. So not too bad, but we did it. You get the same thing if you didn't reduce at first, but your numbers would be a lot bigger, and it's not a lot of fun to do that. So reduce before. All right, there are many ways to set up a proper proportion. Given the triangles in the diagram are similar, one such proportion we could write is a goes to b just as 2 goes to 3. So a goes to b just as 2 goes to 3. That's like the extension beyond that part. Totally fine from the side splitting theorem, by the way. After completing the proportions, cross multiply them to reveal common equation relating sides a to b. So let's finish these proportions. So 15 says b goes to a just as 3 goes to 2, right? Just follow the pattern, finish the pattern. A plus b goes to b, so a plus b is going to go to b just as 2 plus 3 goes to 3. So 2 plus 3 in this case would be 5, right? Now, after you set up all those proportions, go ahead and reduce them if you can. I don't think any of them will reduce. So then cross multiply and see what you get. So when I cross multiply here, I get a ratio of 3a goes to 2b. So that's the relationship between a and b. It's 3a goes to 2b. If I do the same thing here and cross multiply, I'm going to get 5b is equal to 3 times a plus b. And then whenever I distribute that through, I'm going to get 3a plus 3b is equal to 5b. But then it's kind of cool because if I subtract the 3b from both sides, I'm going to end up with 2b is equal to 3a, which is exactly the same thing that I got over here, right? 3a is equal to 2b, 2b equals 3a. So regardless of how we set up these proportions, we're going to get the same relationship between the values. So 2b goes to 3a. Same thing we would have got if we cross multiplied here, right? So 3a is equal to 2b. So just showing you this math is like really involved. There's a lot of things going on here, but it should be kind of intuitive, and we've been dealing with this since middle school. So if this is like really advanced and you're really struggling with it, you're probably going to be okay for the rest of the unit. Don't worry about it too much, but I'm kind of challenge you, I suppose, on the assignment that we're doing today. So good for you, though. Number 21. All right, the measures of two consecutive angles in a parallelogram are 4 and 11. So what are the measures of the 4 angles of the parallelogram? So we do know that these are going to be a ratio of 4 to 11, which is like 4x and 11x. So altogether there's 15x, where x is like our scale factor that we were able to reduce out of our unreduced ratio. And these together have to add up to 180 because they're same side interior, right? So I know the 15x is equal to 180. Divide by 15, which will leave us with x is equal to, should be 12. I think I wrote it down wrong. Yeah, I put 15. It should be 12. Okay, so x is equal to 12. Now that we know that x is equal to 12, we can plug it back in. So 4x would be, what, 48. 11 times 12 would be 132. So if we add those together, sure enough, that's going to add up to 180. So those are our angles, the measurement of the angles there. 23. The ratio of the width and the height of a window is 2 to 7. The width of the window is 3 feet. So this is the ratio of width to height, and then the width is 3 feet. So 2 goes to 7 just as 3 goes to x, in other words. And you can fill in the model and the actual if you want as well. So 2 goes to 7 just as 3 goes to x. Then we're going to cross multiply in this case because we can't reduce anything. So when we do that, we're going to end up with 2x is equal to 21. So 2x is equal to 21, or 7 times 3. Divide both sides by 2, and we end up with x is equal to 10.5. So the actual height of the window would have to be 10.5. All right, 26. I believe this is the last one I'm going to do. It's the last one on the assignment as well. What are the interior measures of the triangle of the extended ratio if the extended ratio is 7 to 11 to 12? Well, 7 to 11 to 12 is going to be like 7x, 11x, and 12x, where x is some scale factor that makes this add up to 180 degrees because it is a triangle. So add them all together, which will give you 30x is equal to 180. Divide them by 30, so we get x is equal to should be 6. Yeah, so we have 6. And if we want to find out what all these angles are, we just have to multiply it back by 6, right? So 7 times 6 would be 42. 11 times 6 is 66. And then this one, of course, would be 72 left over. And so all of these angles together have a reduced ratio of 7 to 11 to 12. And we found out that their scale factor in this case would be times 6. And that will make them all add up to 180 degrees. Okay, so if you have any questions, please feel free to ask. We're going to do this one in class so that we can, so that I can help you guys, because I know there's going to be some pretty tricky questions that we're going through here. So I'll see you guys later. Have a good day.